Hello everyone and welcome back. This is Mr. Keeney, continuing to talk about our Unit 3, which is titled Quadrilaterals, and we are now beginning to talk about parallelograms a little bit more specifically. So we talked about what a parallelogram is and what are the properties. Today we're going to be showing that a quad is a parallelogram. So we're going to be using some of those properties that we learned last time in 8.2, and there's one new one that isn't a property, that is something that we can do to show that a quad is a parallelogram. So we're going to run through, there's 5 different ways, and so if I were to ask you, is this a parallelogram, you have 5 different options, and we are going to talk about those. So the first one is just to show the definition. So number 1 would be show that both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. All right, so what we would need to have in our diagram is our opposite sides would need to have the same number of arrows, because that shows us that they are parallel. The arrows, same number of arrows, kind of like tick marks, they show us that sides and lines are parallel. So that is one way. The other way, which is our first property, is that show that both pairs of opposite sides are congruent. A lot of writing for me today. So very similar to this one, except for instead of doing arrows, we would need to show or have the information, the measurements, that both pairs of opposite sides are congruent. So those are the first 2 that deal with the opposite sides. The next one is going to be talking about opposite angles, or actually it was a property as well. So this is another way. If we were to show that both pairs of opposite angles, if we were to show that they are congruent, that would also be a way to say that this quadrilateral is a parallelogram. So show both pairs of opposite angles are congruent. Okay, so how would that look in our picture? Well, we would have this first pair of opposite angles congruent, and we would have to have the second pair of opposite angles. So both pairs of opposite angles would have to be the same measurement. Our fourth way is about the diagonals. So we're going to show diagonals bisect each other. How would that look? Well, first of all, let's get the diagonals in play. So there's this one, and there's this one. And for the diagonals to bisect each other, we would need them to cut each other in half to give us the smaller and congruent pieces. And the last way is a new way, because these 4, I say they're not new because they're just the properties. We're just kind of flipping this. We're using the converse to say, well, if we know the property, then we can say that these are these are parallelograms. These quads are parallelograms. This one is one you haven't seen yet. So this is another and our final way to show that this would be a parallelogram. So show one pair. And let me reword this. So one pair of opposite sides. Let me say one pair of opposite sides, both congruent and parallel. So this one we only need to talk about one pair of opposite sides. But if we were able to show that they're both congruent, so let me give this, and parallel, that would be enough to say that this quadrilateral is a parallelogram. So there is the complete 5, and what we're going to do now is we're going to go through, if you go to your next page of your notes, and I'm going to scroll down here, is I'm going to give you a quadrilateral, and the question is, what method can you use to show that the quad is a parallelogram? So it's not good enough just to say it is a parallelogram. I'm giving you that. It's what reason. And I'm going to try to highlight it too as I go. So for this first one, I noticed that opposite sides, this is actually the one we just talked about. We have one pair, so this one I would use one pair of opposite sides are both congruent and parallel. So one pair of opposite sides, both congruent and parallel. And I know this because of the arrow and the tick marks on those opposite sides. This next one, number 2, and again, I welcome you guys to pause and try these on your own and look at these properties up here and see which one goes with. But number 2, I notice that here on the diagonals, they are cutting each other in half. So this one would be, yes, it is a parallelogram because diagonals bisect each other. Okay. Number three, oh, this one looks like pretty straightforward. The opposite sides are congruent. That's actually what I'm going to say. Opposite sides, and both pairs, opposite sides are congruent. Number 4 looks interesting because I see two ways. So we could say the same thing. We could say both pairs of opposite sides congruent. And the reason I say that, because if I look here, I have 8 and 8 and 12 and 12. So opposite sides, and I can add that, they will be congruent because they're the same measure. But I'm also seeing, and let me change this, I'm also seeing a little arrow here. So there's two answers. So I'm going to say or. We could say one pair of opposite sides congruent and parallel. So that is that last one we talked about, that one that it showed up on number 1, and there's this 5th one right here. If I'm able to show, like on number 4, that one pair, so 8 and 8, not only are they equal to each other, they're parallel to each other. So that would be 1, 2. And then number 5, let's see here. I got opposite angles are congruent. Opposite angles congruent. And this one is both pairs. I keep forgetting to put that. Both pairs of opposite angles congruent. And then the last one here, we could say the same thing, really. There's actually two reasons. I'm looking at 120 and 120. And then I'm also looking at 60 and 60. So I could say again, both pairs of opposite angles congruent. But I do want to point out that there is another one we could use here. So another big or. If I had to look at 60 plus 120, well, that's 180, and 60 plus 120 is 180, and 60 plus 180 is 180. And you get the point. But consecutive angles are parallel. So that's another one we could have used. So 2 options for that one, 2 options for number 4. Those are the ways. You'll have some questions, as you can imagine, on your assignment. They'll go over that. Let's get to solving now. We are going to solve, and we just got 2 here, for the value of x that would make this quad a parallelogram. So the first one looks like we're talking about diagonals. So if I'm wanting the value of x to make this a parallelogram, we would want these to be congruent to each other. So we would want 9x minus, not 1, minus 31 equal to 4x minus 1. That's what we'd want. So let's go ahead and solve this to find the value of x that would make that true. I'm going to take away 4x first. Oops, I did the wrong cancel. The cancel goes over here. 5x minus 31 equals, bring down the negative 1. I'm going to add 31 to get it to the other side. And go here, 5x equals negative 1 plus 31 is 30. And then we would divide by 5 to get x equals 6. So boom, x equals 6. And that would get us equal parts of that diagonal that's being bisected. And the last one here, these are consecutive angles. And remember, they should be supplementary, which supplementary means adds up to equal 180 degrees. And maybe I should be a little bit more clear about what I'm writing here. Put a little colon, how about that? So supplementary adds up to equal 180 degrees. So for this to be a parallelogram, I need those two angles to add up to equal 180. So that'd be 5x minus 10 plus 12x minus 14 equals to 180. And then I need to find the value of x that makes that true. So I just need to solve this equation. So I got like terms that I'm going to add up. The first one I see is 5x and 12x, which is 17x. And then negative 10 and negative 14 is negative 24, and that equals 180. I'm going to add 24 to both sides. So So those cancel, and I got 17x equals 204. We'll divide by 17. I did this beforehand, as you can imagine. So when you use your calculator, 204 divided by 17 will equal 12. All right, so that is it for this. It's a little bit longer, a lot more writing. The big thing I would say is this right here, knowing the 5 ways to prove or to show that a quad is a parallelogram. Let me know if you guys have any questions. If not, I will talk to you guys later.